Assalamualaikum warahmatullahi wabarakatuh. Today we will learn about chapter 1, functions, limit and continuity. So this is the subtopics covered in this topic, which is functions, have properties of function, operation on function and graph. While limit we have 5 subtopics here, and continuity we have 2 subtopics. So for the week 1, we will cover the topic of functions and limit. Okay, so actually what is a function? Okay, so function is function is used to describe the relationship between two variables. So for example, you have a function which is basically function we see previous class. We have a function f(x) is equal to x. So the relationship between f(x) and x here, we have two variables. So this is the first variable f(x), or sometimes we use f(x) also sometimes we call is equal to y, and we have the second variable x. Okay, so one quantity depends on another, so it means f(x) and x is depend on each other, so that why we call it as a function. Then a function must be maybe one-to-one or many-to-many function. Okay, so a function is a rule that assigned to each element x in a set D exactly one element. We call it as f(x) in a set E. Okay, so f(x) basically we read it as f of x. So in a function, we have two things that you need to know about a function, which is range and domain. Okay, so range is all the possible value of the values of f(x). Let's say you have a f(x) exists, basically f(x) is on y-axis, so all the point at the f(x) axis we call it as a range. Okay, so f(x) as x through the domain, so x y-x is the horizontal line. Okay, x horizontal line, so all the value at horizontal line we call it as a domain. Okay, simple way, x is and the input. Okay, x as input. Okay, so for a function f(x) is equal to x, so x is the input. What means by input? Input is the independent variable. Okay, what is independent variable? Independent variable means that this variable not depends on other function. So the independent variable can appear by itself. Okay, so f(x), okay, f(x) is the dependent variable because f(x) depend on the value of x. What the output? Okay, output, if x we call it as output, then f(x) we call is the output. So the value of outputs depends on the input itself. Okay, so the process of the function is like this: input, substitute into our f, then we will get the output f(x). So a symbol that represents an arbitrary number in the domain of a function f is called the independent variable that I have said previously. So a symbol that represents a number in a range of f we call it as independent. Okay, so y or f(x) is dependent, x is independent, x, y or f(x). Okay, so function must be one-to-one. Okay, what is one-to-one? One-to-one means you have a function one input and also one output, or maybe you have many input. Okay, let's say input 1, input 2, input 3, and it will give you one output. Okay, that we call it as a many-to-one function. Okay, so one-to-one function also called injective function. Okay, then many-to-one function if there are y values that have more than one x in the value of MAT onto that. Okay, we look at the function of domain and range, how to find the domain of the range. Okay, look at example 1 here. So for example 1, number 1a, so we have a function of fx equal to x. Okay, so we know this is the function of linear function. Okay, we didn't have any value of c. Okay, so c is equal to 0. Okay, so when c is equal to 0 means our graph touch at origin 0, 0. Okay, why this linear function is positive? Because the constant in front of x is positive 1. Okay, so as I mentioned previously, domain is all the point in x-axis and y is all the point at y-axis or fx-axis. So if we look at this graph, the value at our left hand side we go down until a several number that we didn't know. At the end of the number, what is the exact number for this function? Hence, we conclude that our left hand side is negative infinity, while our positive hand side, okay, at our right hand side, okay, right hand side, this graph, this function, we go up until we didn't know until where, so we conclude it as a positive infinity. Okay, so this function have a domain of df from negative infinity from left hand side, okay, to the positive infinity at the right hand side. Okay, this is the domain of fx which we look at the x-axis. Okay, why? In order to find the range of fx, so we need to look at the value at our top and bottom from the function. Okay, so y-axis here. So this graph, we go move up until we didn't know until where, so we conclude it, we go to the positive infinity at our top, and we go down until negative infinity at the bottom. So our range also same with domain, which is from negative infinity at the bottom, move to the positive infinity at the top. So our range Rf is equal to negative infinity to positive infinity. You need to remember the interval is always open for negative infinity and positive infinity. Okay. It's also same explanation goes for the example B. Okay, because we didn't have any interval at the function of A and B. We didn't have any interval. So the reason for domain and range for example B is same like the example A. Okay, even though example B has a bit different, which is example B, the graph is negative because of negative 2 at the constant in front of x. Okay, but it will also give the domain of negative infinity to positive infinity. Why? Because this graph, we move to the left hand side until negative infinity, and we move to the right hand side until the positive infinity. The same goes with the y-axis, which is at the lower or bottom side. We move to the negative infinity and move up to the positive infinity. So the range of this function also from negative infinity to positive infinity. Okay, we look at example 2. Okay, so example 2 is the example of quadratic function. So for the f(x) equal to x squared. Okay, so x squared means this function didn't have any y-axis. So the minimum point will touch at origin 0, 0. Okay, so as I mentioned previously, the domain is from the left hand side at until right hand side and right hand side. Okay, so this function will move to the left hand side. We didn't know any exact value, so we put it as negative infinity. And it also go to the right hand side, and we didn't know also the exact value for the right hand side, so we write down here as positive infinity. Okay, but for the range, we look at the minimum point at this graph. So the minimum point at this function is at the origin 0, 0. And then from 0, 0, the graph will move up until positive infinity here. So the range of this quadratic function starting from 0 to positive infinity. But remember, you need to close interval for this function. Why we need to close the interval? Because this function is include the origin of 0, 0. Okay, so this is the range for this function f(x) equal to x squared. Okay, we look at the function of f(x) equal to x squared minus 2. Okay, the explanation same with the example 1, but example 2 we have a little bit different compared to example A. To A and to B a little bit different because of example B we have y-axis which is negative 2. Okay, y equal to mx plus c. So our c now is equal to negative 2. Okay, why we get negative 2? Because when our x is equal to 0, so y or f0 is equal to 0 square minus 2. That's why our fx or y is equal to negative 2 when our x is 0. So minimum value for this function is negative 2. Okay, but the domain is the same like our previous example from negative infinity to the positive infinity because of our left hand side move to the negative infinity and our right hand side move until positive infinity. Okay, but the range a little bit different because of the lowest point or the minimum point now change to negative 2. Okay, so we must be start at point, the minimum point which is negative 2 here, and then this function move upward until the positive infinity. So the range of this function is from negative 2 to positive infinity. For example 3, so this is the function for the radical function, square root. Okay, so the first one, in order to more understand how to find the domain and the range, you need to look at the graph. Okay, so this is the graph of quadratic function. Because of this function didn't have any y-axis, so it started at the point of origin 0, 0. Okay, so our domain at our left hand side starting at 0 and include, because this function, if we substitute the value of f0 is equal to 0, means the value of 0 exists. Why this function of radical function didn't start at negative value? Because when we have negative, let's say we have negative 1 as our function, when we substitute negative 1 into the quadratic function, square root function, we will get math error by press our calculator. Okay, why math error? Because this is the conjunction is this cannot find by using of square root -1. That's why our domain start from 0 until our right hand side move until positive infinity. And then it same goes to the range. Okay? Range at our lowest value starting from y equal to 0. Okay, then move upward at the bottom. Sorry, at the upward. And the upward value must be positive infinity. So, our domain and range for this radical function fx equal to square root of x is same, is close interval from 0 to positive infinity. Okay, we look at example 3b. So we have a function of square root of x minus 2 plus 3. So in order to solve this equation, we need to take the value inside or in quadratic, in radical function, which is x minus 2 here, the value must be greater than or equal to 0. So the value of x must be greater than and equal to 2. Okay, so if we want to draw the graph, it's become like this. Okay, if our x is equal to 2, we just replace our f2 is equal to square root of 2 minus 2 plus 3. So we will get 3 here. Okay, so when our x is 2, our y is 3. Then it will move upwards. Okay, so this is our function fx equal to square root of x minus 2 plus 3. So we want to find the domain. The domain must be starting at the point 2 here. Then this is black dotted. Okay, so must be closed interval from 2 until positive infinity. Okay, then our range. Okay, range we need to look at the lowest point starting of this graph. Okay, so the lowest point here is 3. Okay, so 3 move upwards until positive infinity. So our range become RF is equal to 3 infinity. Okay, so this is the function of operation function, which we have summation, difference, product, quotient, and composite function. Okay, let me look one by one. Okay, this is the example of composite function. If we have gfx is also equal to g, and inside of our function of g, we have fx. So, example 6, we have two functions, which is fx equal to 2x plus 3 and gx equal to x minus 1 square plus 5. Okay, so the first question, we want to find the domain and range of gx. Okay, since the domain for gx, okay, so if we look at here, okay, function of gx is quadratic function. Okay, so quadratic function, if we look at our previous example, our quadratic function, the domain must from negative infinity to positive infinity. But for our range, we need to look at our y-intercept. Okay, how to know our range? We need to substitute the value of x is equal to 0. Okay, in order to find the y-intercept, we must substitute our x is equal to 0. Okay, then range x equal to 0. 0 minus 1 square. Sorry, that's not our domain for quadratic function. Okay, the value or number outside from our quadratic function, this is our y or y-intercept or c. Basically, we have a function y equal to m x square plus c, like that, right? Okay, so c is our y-intercept. So C is 5 here. So if we draw the graph, it's become like this. We have a minimum function which is starting at our bottom minimum point. Okay, sorry. So 5. Point Y kita 5 here. Y intercept. Okay, so that's our range must be from 5 to positive infinity. Okay, so the second function, the second question, we want to find g, f, x. So this is the example of composite function. So the function of fx inside of g, which is the function of fx is 2x plus 3. So this function fx, we substitute into our function gx. Okay, in the given question, we have gx equal to x minus 1 square plus 5. Then we replace the value of x here with 2x plus 3. Okay, so the value of x now become 2x plus 3 because we want to use the composite function by substitution 2x plus 3 into the function of gx. Then at the back, you just write down back negative 1 minus 1 square plus 5. Okay, then you expand this function. Simplify at the bracket first, 2x plus 3 minus 1. Then you will get 2x plus 2 plus 5. Okay, then from here you expand quadratic function here and then plus together with 5 and you will get the function is 4x squared plus 8x plus 9. Second, we want to find fg2. Okay, so the composite function is f. Inside of f, we have g2. Okay, so remember, our function of gx is gx equal to x minus 1 square plus 5. But now, we want to replace the value of x with 2. So, you just substitute the value of x here with 2. So that you will get 2 minus 1 square plus 5. So, first of all, you simplify the number in front or inside the bracket first. At the end, you will get 6 here. So, f6. Our original fx is equal to 2x plus 3. So, now we substitute our x with 6. So, it's become 2 times 6 plus 3. Then, we simplify this one. 2 times 6, 12, plus with 3, then we will get 15. Then, we want to find f power of 2x. Okay, this composite function have two same function, which is f. Inside of f, we have fx. So, we have f inside 2x plus 3. So that we will have 2 multiply with 2x plus 3 plus 3. Okay, then we open one by one. Open the bracket first. 2 times 2x, 4x. Plus 2 times 3, 6 plus 3. So at the end, you solve, then you will get 4x plus 9. Okay. Next, we want to look at the inverse function. What is the inverse? Okay. Let's say you have an input x. Okay, input x and you have a function of f. From input, if you know the value of input, then you can get the value of output, which is y or fx here. But we want to find the inverse function. Inverse means from y, from output, we want to find our input. So we can find our f inverse. F power of negative 1 is symbol for f inverse. Let me look at example 7 here. So we have a function of fx is equal to 2x plus 3 over x minus 1. and we have a function of gx equal to 1 minus 5x. So the first question, we want to find the domain and range of fx. Hence, this is the radical function. So in order to find the domain, we need to solve for the denominator first. We just take the value at denominator, which is x minus 1, and then the value of denominator must be not equal to 0, because when you have a number, any number, doesn't matter 1 over 0, 0 over 0, if you have 0 value at your denominator, then it will give you MAT error. Why MAT error? Because you didn't have, nobody will pass. Okay, let's say you have 1 pen, but you didn't know to who you will give that pen. So your pen didn't know to give to who. Okay, so that's why they have no solution. 0 over 0, that's why it's become MAT error. So from here we solve. From x is equal to 1 must be not equal to 0. Then we will get the value of x is not equal to 1. So we know our domain must be at x interval or horizontal interval. So if we have a value of 0 here, so it's from left to right, but it have a white dotted here. So white dotted means they are not closed interval. Okay, so the domain must be from negative infinity at our left hand side until 1, but this is open interval, and union with 1. Okay, also open interval because this is a white dotted. Okay, then we move until positive infinity at the right hand side. Okay, so this is the domain. Next, how to find the inverse? Okay, in order to find the range of fx, we need to know the f inverse x first for radical function here. So, how to find the f inverse? We just take our original function, which is 2x plus 3 over x minus 1, let that function is equal to y. Then we multiply our y with x minus 1. Then we expand y by 1. Yx or xy minus with 1 is equal to 2x plus 3. Okay, then we rearrange back any number that have a variable of x. We move to the left hand side. Why any variable that didn't have any x, we move to the right hand side. Then we factorize this function, and then we solve. We make our x as the subject. So since this is a multiplication, so we bring this multiplication to the right hand side, and we will get 3 plus y over y minus 2. Okay, so our f inverse x is equal to 3 plus x over x minus 2. You just replace the value of y here with x. Okay, so this is the inverse function. Okay, next b. Okay, b, we want to find, okay, this is b, we want to find f inverse g2. Okay, f inverse g2. So we have f inverse outside and g2 inside. So our function for gx that are given in the question is gx equal to 1 minus fx. Okay, so f inverse 1 minus 5 multiplied by 2, because we already want to replace the value of 2 with x with 2. Okay, then we solve at the bracket first. 1 minus 10, then we will get negative 9 here. Then we substitute f into our f inverse that we have found previously, which is f inverse equal to 3 F inverse is equal to 3 plus x over x minus 2. But now our x is negative 9. So just substitute our x with negative 9 here. And we solve, we will get negative 6 over negative 11. So simplify negative divide by negative, then we will get positive infinity, which is positive 6 over 11. So this is the inverse function. Then we look at the piecewise function. So piecewise function, example, you have 3 functions here, which is fx is equal to x plus 2. And the second one is fx equal to x squared plus 2. And the third one is fx is equal to 4. So we have 3 different functions with the value of fx same. Okay, so we look at the graph in order to make our easy to understand more. Okay, so for the first one, we have linear function. Okay, linear function, which is fx equal to x plus 2. So fx equal to x plus 2, interval starting at x less than or equal to 0. Okay, so for this function, x plus 2 means starting at 2. Okay, starting at x equal to 2. So when we draw the function, okay, starting at x equal to 2 here, and must be greater than 0. So this is fx equal to x plus 2. Okay, for the second one, fx equal to x squared plus 2. So the function is quadratic. So the minimum point is at x equal to 2 here. So this is x squared plus 2. fx equal to x squared plus 2. Then the third one is fx equal to 4. Means our y always 4 here, but starting from 0 to 2. Okay, so this is the example of piecewise function. But let we look at the original question. What is the function that involves piecewise function? So for example, we have 3 functions here, which is the first one, h x is equal to 5 with the interval of x less than negative 3. The second one, hx is equal to x squared, quadratic function, the interval in between negative 3 to 2. And the third function is hx equal to 10 minus x. Okay, so the first one, we want to find h negative 3. Okay, in order for you to more understand, you better draw the number line first. Okay, number line. So look at the number involved at your interval. So we have negative 3 and 2 here. Okay, so less than negative 3. Look at in the interval, we didn't have any equal function here. So this means white dotted move to the left. Okay, so this value 5. Okay, any interval from negative infinity to negative 3, it will give the function of hx equal to 5. Okay, for the second function, which is hx equal to x squared, in bit interval, negative 3 includes, because equal sign here, include black dotted, until 2 also include because of equal sign also here. So the function involved is x squared. So the quadratic function is in between negative 3 and 2. And then the third one is starting from 2, not involved. So greater than 2, the function is 10 minus x. Okay, so the first one, we want to find h negative 3. So h negative 3, we look at this interval. Okay, this is our negative 3. So if we move to the upwards, we look at the dotted, black dotted. Okay, so black dotted or blue dotted here in this function. So this function is x square, means quadratic function. So we need to use our function for quadratic, and we substitute with negative 3. Why we cannot take the other two function h equal to 5, hx equal to 5 or hx equal to 10 minus x? Okay, why? Because another two function cannot involve the interval of negative 3 here. The only function that have black dotted at x equal to negative 3 is the function of quadratic, which is x square here. That's why we put our h negative 3 equal to negative 3 square. We take our second function here as for the to answer the first question. Then we substitute, we get the h3 negative 3 is equal to 9. Okay, then we want to find h5. So where is the value of 5 here? Okay, the value of 5 must be greater than 2. So the function involve the value of greater than 2 is function of 10 minus x. So we just use the function of 10, and the value of x itself we replace with 5. Then we substitute, we will get 10 minus 5 equal to 5. Okay, then the second question, we want to sketch the graph. Okay, for the graph, the first one is starting at interval negative 3, and to the left hand side, the function involved is hx equal to 5. Okay, so from negative 3 to the left hand side, okay, because the value is 5, means our y is 5 here. Okay, for the second interval from negative 3 to 2, it involves quadratic function here. So this quadratic function didn't have y-axis, means our intersection is at 0, 0 here. So we will touch 0, 0 and move upwards until negative 3, and then black dotted because of equal sign here. Then move upwards at our right hand side with the value of 2 here. When how to know the value of 4, you need to substitute into the function. Let h2, so we will get 2 square and equal to 4. That's why our hx is equal to 4 when our x is equal to 2. But when our x is equal to negative 3, so negative 3 square, then we will get 9. That's why when our x negative 3, then we will get our x is equal to 9 here. Okay, this is our second function. Then our third function, we have hx is equal to 10 minus x. Okay, so when we have x is 2, so h2 is equal to 10 minus 2, then we get 8 here. Okay, why we choose 2 here? Okay, because the interval for this function starting at 2 but must be greater than 2. That's why the point here is white dotted. Okay, if you have equal sign, then it will become black dotted. But because of no equal sign here, so we just write down white dotted here. So this is the graph of these three functions. Then question C, want to find the range of hx for the domain of negative 3, x, and 2. So the domain is starting at 0, okay, the lower or minimum point, until the maximum point is 9. Then, okay, this is the family graph of function. We have linear function, quadratic function, cubic function, okay, ni absolute values function, reciprocal function, exponential function, logarithmic function, and square root function. So you need to familiar with all the family graph of function. Okay, then we go to limit. Okay, what is limit? Okay, limit must come from one side limit and two side limit. Okay, what is one side limit and two side limit? Okay, so limit, even though in our life we also have a limit. We need to eat during a certain period when we feel empty our stomachs. We must eat. Okay, so sometimes when we drive a car, we also have a limit. Okay, at village or at the toll. Okay, we have a certain limit, 30 km per second, 30 km per hour, 110. That is our limit when we drive a car. So it also have a limit in a function. Okay, because function is very related to our daily life. Okay, in a function, let's say you have fx. Okay, so our limit must approach from left hand side. So any value approach from left hand side, we write down it as a power of negative. X approach to a power of negative, while right hand side is x approach to a positive. Okay, so in order to ensure the limit exists, that function must equal value from right and left hand side. So you need to identify first what is the limit from left hand side and what is the limit from positive right hand side. Okay, so when this both value give you the same value, so you will conclude that the limit of the function is exists. Okay, we look at the example 1.2, limit example 9. Okay, to be more understand for this topic. Okay, let's say we already given the graph like example 9 here. So the first question, we want to find limit fx when x approach to negative 3, negative. So we look at the value of negative 3. So negative 3 negative must at left hand side. Okay, left hand side from negative 3. Negative 3 positive at right hand side from negative 3. So if we look at this graph, negative 3 negative, this graph move to the negative 3 and we have black dotted here, means the value is 3. Okay, means when our x is negative 3, so our y is 3 here. That's why the answer is 3. Then we want to find fx when x approach to 0 positive. Okay, so 0 positive, this is our 0. So 0 positive is our from right hand side. So from our right hand side, okay, this is the function of limit approach from right hand side, but it will touch at origin 0, 0 with include. Okay, so the value of fx when x approach to 0 positive is 0. Okay, then next we want to find fx when x approach to negative 3. Okay, negative 3. Okay, if we look at here, x approach to negative 3 from left hand side is 3, and x approach to negative 3 from 3 positive from right hand side also 3. Hence, we conclude that fx, limit fx when x approach to negative 3 is equal to 3. Okay, next, we want to find limit fx when x approach to negative. So, first of all, we look at the value of 2 here because we want to find the approach from 2, but we want to find from 2 negative, so right hand side. So from right hand side is involved linear function. So when our x is 2, our y also 2 here. So limit fx when x approach to 2 negative is equal to 2. Okay, so the number E, we want to find limit fx when x approach to 2. Is it exist or not? Okay, from the question D, we already find limit fx when x approach to 2 negative will give us the value of 2. That means from left hand side is 2. But then we need to find the value for limit fx when x approach to 2 positive. So from 2 positive, the value is 4, y4. When our x is equal to 2, from right hand side means the function is 4 here. So the value is 4. So from 2 negative 2, from 2 positive 4. So both value is not equal. 2 is not equal to 4. Hence, the limit of fx when x approach to 2 does not exist because of two different value of 2 and 4 here. Okay, so this is the basic theorem of limit that we have. When we have addition, we can separate one by one, we calculate one by one, and then end up we plus together. Same goes when we have negative 2 function and it's involved negative, or it's involved different between that 2 function. We can solve by solving the bracket first, or you can separate one by one limit of fx and then you minus with the limit of gx. At the end, you will get the answer and solve a minus b. Okay, if you have a constant of fx, you can put the constant in front from your limit. Write down the constant in front and then follow by limit fx when x approach to c. Let's say the answer for limit fx when x approach to c, you will get a, so it will give you ka. Okay, so for multiplication, if we separate it, we become limit of fx as approach c multiplied by limit of gx as approach to c. So let's say the value of limit fx when x approach to c is equal to a. Then you will get limit of gx as approach to c equal to b. Okay, you solve one by one. At the end, you multiply both. If you have a question rule, a question, so you can separate like this. You solve one by one. Find the limit for the above first at your numerator, and then later on you solve for the limit at the below or at your denominator. Okay, after you get the answer at the end, then you combine this together. Okay, then we also have a power function. If a function is power, you can solve the limit of function first, and then after you get the answer, you multiply or power that answer. Okay, or you have a square root of the function. Okay, you can put square root outside. You calculate the limit of fx when x approach to c first. Then at the end, you square root that answer. Okay, let me look at the limit of polynomial function. So if we have a limit of fx when x approach to c must be equal to fc. So the function of 2x squared plus x. Okay, when we want to find x approach to 2, we just substitute the value of x with 2 here. Remember, when you substitute the value of x with the number, look at this, the limit lost. The limit doesn't exist yet. Okay, means when the variable, we remove the variable and replace with the number, and limit also we need to remove from our function. So what happened to the function is only the number 2 times 2 square plus 2. Then we solve this, we will get the value is 10. Okay, example 2. Example B, same. We just replace the value of x with negative 1. 1 by 1. At the end, you just calculate this and you solve, you will get negative 12 here. Okay, then example 11. This is the radical function. So for the radical function, First of all, you just substitute the value of denominator and numerator by substituting the value of x that give to us in the approach. So x, we just replace with -1 here. So when you substitute, you will get 0/0 here. But you cannot just left down your answer by 0/0 because you need to factorize this function. So we factorize this function, x squared minus 2x minus 3 factorize, it will become x minus 3 multiplied with x plus 2. Then we can cancel the same value x plus 1, we can cancel. What left is 1/x minus 3. And we just replace the value of x with -1. And we solve, we will get -1/4. Basically, most of students substitute all the value of x at the function. But when he or she gets 0/0, most of them write down 0 here. Please don't do the same mistake. 0/0 is not equal to 0. Okay? Because 0/0 will give you math error. Because you didn't have or you cannot move to others. 0. Your denominator cannot be 0. Okay? Any number, doesn't matter, 1/0, 2/0, 3/0, you cannot let your denominator equals to 0. But if you get the answer 0/0, you need to find another way or another alternative in order to solve this limit. So what is the alternative? Let me look at the example B. So if we have 9 minus x, 3x over x squared minus 3x. First of all, you must substitute the value of x with 3 into the function first. But when we substitute, we get 0/0 here. Okay, so when you get 0/0, you need to factorize that function. For denominator and numerator, both you need to factorize. So we factorize at our numerator, it will get 3 times 3 minus x over x multiplied with x minus 3. Okay, but you need to multiply numerator by -1 because we need to have the same value at numerator and denominator in order to cancel both up and down. So when we have the same value, x minus 3 at numerator, x minus 3 also at denominator, so you can cancel both. So what left is -3/x. And then from here, you substitute the value of x with 3. Then you will get -3/3, which is equal to -1. Okay, most of students do the mistake. Okay, what is the mistake? They don't factorize with -1. You just cancel even though not equal sign. Cannot. In order to cancel both up and down or to cancel both denominator and numerator, you have the same value exactly, top and bottom. 2/2. 2/3 tak boleh. Okay? Ataupun -x over -x plus -1 dengan x plus 1. You cannot simplify, cancel like that. You need to factorize first. Same function above and bottom or numerator and denominator in order to get the in order to cancel that function. Okay, look at example next. We have exponential function. Okay, so first of all, as usual, we just substitute the value of x with 0, and then we will get 0/0 also. But as I mentioned previously, you cannot left the answer in terms of 0/0. So what you need to do is, you need to factorize that function. So how to factorize that function? Okay, so you just factorize the function at the denominator. Okay, so factorize, then you will get e power of x is equal to e power of x multiply with 1 minus e to the power of x over 1 minus ex. Then we can cancel up and down. So what left is e power of x. Now, when we substitute the value of x with 0, so it's become e power of 0 equals to 1. Any number power of 0 is equal to 1. X power of 0 also equal to 1. 10 power of 0 also equal to 1. So you no need to press your calculator. Okay. So how to solve this exactly? It's like you just assume e to the power of x. We substitute with other variable like m minus m square over 1 minus m. So we factorize top and bottom with the same number or same value of the constant in front, and then we can cancel it. So what left is m only. Okay, example 2. Finding the limit of piecewise function. Okay, so we have a piecewise function here, which is limit fx when x approach to 4. Okay, for this example, we have two functions. The first one, fx equal to square root of x, and then the second one, fx equal to x square minus 6x plus 8 over x minus 4. If you have a piecewise function, better you draw the number line. So the number line, you have a number 4 here. You just write down 4 here. So the first one, the interval, we have equal sign. So black dotted and then move to the left hand side because less than, then you have a function of fx is equal to square root of x. And then another one is x greater than 4. So for x greater than 4, starting at 4 to the right hand side, which is the interval is x square minus 6x plus 8 over x minus 4. Then we have a limit of fx when x approach to 4 negative is equal to limit of square root of x when x approach to 4 negative. Okay, why we put square root of x here? Because 4 negative at left hand side. Why another function, radical function, is x squared minus 6x plus 8 over x minus 4 at our right hand side. Hence, that's why we choose function of square root of x for x to the power of 4 negative. X approach to 4 negative. Okay, so we just substitute the value of x with 4, then we get square root of 4, and we will get is equal to 2 here. Okay, then we want to find for limit of fx when x approach to 4 positive. So 4 positive means at 4 from right hand side. So the function involved is x squared minus 6x plus 8 over x minus 4. So first of all, as usual, we just substitute the value of x with 4. And then we will get 0 over 0. Remember previously, we cannot left our answer in terms of 0 over 0. So what we need to do, we need to factorize for the above function, top and bottom, or numerator and denominator. So when we factorize this function and we solve, we will get our last answer is equal to 2. So from here, we conclude that our limit from left hand side, which is fx, x from 4 negative, and the limit of fx from right hand side, which is x approach to 4 positive, have the same value, which is 2. Hence, our limit fx when x approach to 4 is equal to 2 exists, because the right hand side and left hand side give us the same value, which is 2 here. Okay, even though the function is different, but the final answer is same. So that's all for the first